Good day, everybody, and welcome to the Maths Genius Club, which is brought to you by the Education Support Forum, which hosts the podcasts. You can find the podcast on iTunes, on Iono, on Spotify, and most of the places that host podcasts, we're there. So today, we're going to be talking about mathematical thinking. Mathematics is that subject that when people think about it, they become very, very anxious because mathematics has been packaged in such a way that it's actually scary to the normal human being. So, you'd have to ask yourself a question to say, why is it that about 70 to 80% of people on earth are afraid of maths? Is it that those people are dumb, or is it because the subject is being presented in a very abstract way that is far removed from people's lives? So today we want to talk about mathematical thinking. If you think like a mathematician, how is that going to help you succeed in life? And where do you use mathematics in life, explicitly and implicitly, So you find that when we talk about mathematics, some people have said mathematics is a language, right? A language that is composed of numbers and symbols and is used to make sense of the world. So it's a way of describing the world, because without mathematics, then we wouldn't have physics, we wouldn't have chemistry, because people would not be able to quantify, quantify whatever it is that they were experiments they were carrying out. So it is important to understand that you have to understand the language of mathematics before anything else. So, for example, I always ask people to say, give me the palindrome of 55, right? So palindrome of 55. So that's a math question, but more importantly, it is actually a language problem, because if you don't know what the palindrome is, you'll never, no matter how smart you are, you'll never be able to answer that question, because you have to have the definition of palindrome for you to be able to answer. So it's not a math problem, it's a language problem. So now you find that a lot of kids are going into exams and they'll be asked, give me multiples of 4, right? So the moment you don't know what a multiple is, there's no way on earth you're ever going to be able to answer that question, because you don't know the definition of a multiple. So in other words, you have to actually learn the jargon of mathematics. That is the terms that are used there. If somebody says this is an integer, what does that mean? If somebody says this is a rational number, what does that mean? So it means our teachers should take as much effort in the methods of calculation of arithmetic, in defining terms, such that students internalize those terms and will be able to communicate effectively using the language of mathematics. So it's important that everybody looks into that. So now, where we want to look at is a situation whereby we have learned these terms, we have understood them, we can now calculate, then what? Where does it apply in life? Right? So, what is the reason that we are asked questions? We are asked to solve problems from grade 1 to 12 or to varsity. We're just solving problems. And maths problems are not necessarily easy. If you hear somebody say maths is easy, chances are high that they're a liar, because maths gets progressively difficult. But you have to have the resilience, you have to have the fighting power, you have to have the tenacity to sit down and try until you get that answer. Because without that, then you give up and that's it, and you start to hate maths. So I believe that the maths classroom is almost like a simulation of life, because in life, at any given point, you have a problem that needs solving. At any given point, whether you are rich or you're poor or you're healthy or unhealthy, at the end of the day, at any given time, you are solving a particular problem at any given time. Any decision that you've ever made in your life, you made it based on some reasoning of some sort, whether logical or emotional or whatever. But at the end of the day, you were supposed to solve a problem by making that decision, right? So that means that if you learn how to solve problems and make decisions, then I think generally you will have a better life than somebody who doesn't have those skills. So in mathematics, we're just teaching you how to be a problem solver, how to think in a structured way such that you can arrive at the best possible answer, right? The only problem that maybe we have in the maths class is that there's too much emphasis on the correct answer. Because in life, you're never going to have one answer that fits all, like a one size fits all. There are always going to be 10 possible solutions, 12 possible solutions. You have to pick the one that is best for you, right? So, but anyway, the maths class is a simulation of real life because it's training you to be a prolific problem solver. Somebody who, when faced with any type of problem, you're able to chart a way forward, right? Using a framework that makes sense such that you come up with the best possible answer, the optimal solution, as some call it, right? So it's important now to say, wherever you are you thinking like a mathematician? But now the question is, how do mathematicians think? What structure do they use when attacking problems, right? So I'll give you a basic skeletal framework that you can use. Obviously, most of you will have encountered this framework somewhere, somehow, because it's taught in business schools, it's taught in other subjects, but obviously they give it other names, right? You find, say, for example, in software development, something called the software development life cycle, right? That is problem solving, and the different stages of the SDLC. That is thinking in a structured way. Or engineers, when they're solving a problem, when they want to build a bridge, all the steps that they take, that's thinking like a mathematician, right? Statisticians, geographers, everywhere, business people, doctors, they all solve problems on a daily basis, and there's some structure of some sort which can be summed up into 5 steps. So the first step in solving any problem is actually identifying the problem. So identifying the problem is one of the most difficult things to do, because you find that in our schooling system, using maths as a proxy, right? You find that they give you the problem. So that means they've robbed you the opportunity to actually go out there and find a problem. So finding the problem is very difficult, and if not done correctly, it means that you are going to solve for the wrong problem. Maybe you solve for the symptoms of the problem instead of solving for the root cause of the problem, right? So it's important that the first step be identification of a problem. So you have to master the skill of identifying problems from their fundamentals. Like Elon Musk says, solve not by analogy, but from first principles, like a physicist, right? So it's important to be able to identify a problem. Then, once you've identified a problem, the second step is to sorry about that. The second step is to understand the problem. Right. When I say understand the problem, this is where, if it's in business analysis, you're saying, what is the problem? Who is affected? When did it start? Like you're asking all those questions, the W's and all that, in understanding and interrogating the thing that you think is a problem, in understanding it and analyzing it fully. Once you've understood the problem, right? So we said first step is identify a problem. Second step is understand the problem. The third step is to devise a plan. Now, this is where most people rush to, devising a plan. People come up with plans to solve problems before they've even understood the problem, before they've even ascertained for real that the problem they're solving is the real problem. Understand? So this is the how. A lot of people know how to do things. And unfortunately, most of the education systems around the world teach mathematics as a subject of how to do things, where you're going to say, I'm going to use Pythagoras theorem, not informed by any meaningful understanding of the problem, right? Or contextual relevance, you know? So it's important that we don't jump into the how, into the methods, into the tactics and techniques and all that, right? And formulas. But first of all, identify the problem, understand the problem, then you can devise a plan, of which it doesn't have to be one plan. You can have multiple plans and choose the best plan. In mathematics, the plan is what? Is the formula. To say which formula, based on my understanding of the problem, which formula is the best to use in this circumstance, right? Once you've devised the plan, as we know in Africa, we are good at writing white papers and green papers, policy papers that are amazing, but the problem is that our execution leaves a lot to be desired. So it's important that when you've devised a plan, then you need to execute. Execute the plan, right? Carry out the plan. That's important. So once you've carried out the plan, then the fifth thing, which is not necessarily done at the end, but can be done at every step, or all the 4 steps that I've mentioned so far, is to evaluate. How many people have failed an exam, not because they didn't know what they were doing, but maybe they were making silly mistakes and they didn't check their work for simple errors and it cost them, right? So evaluation is important at every step. When you're identifying the problem, have ways of checking the validity of your assertion that this is the problem. And in understanding the problem, have some checks and balances as well to say, how do I know that I've really understood the problem, right? Then the how, that's another one. And carrying out the plan, you should also check if I implemented it the way that we planned it, or are there any deviations and by how much, and how does it affect everything? So this is you thinking like a mathematician, but you use these principles on a daily basis in a very casual manner that you might not even realize that you are an amazing mathematician. A mathematician is not necessarily someone who can calculate big sums, using mental mathematics, or someone who speaks has got high verbosity and speaks big words, terms in mathematics. No, a mathematician is a problem solver. A mathematician and an entrepreneur are just the same people. They are people who identify problems and find ways of solving them for the betterment of humanity. So remember the 5 steps. Identify the problem, understand the problem, devise a plan, carry out the plan, and evaluate. That is how mathematicians think. That is what we call mathematical thinking. But remember, for you to be effective, you have to understand the language of mathematics, understand the terms, definitions, the relationships between entities, and you will have no option but to succeed in mathematics and to succeed in life as a prolific problem solver. So thank you very much for your time. Meet you again in the next segment.